Welcome back, guys. I hope all of you will be fine. So this is question 3.30 and today we are going to discuss it in the context of the random variables and probability distributions. Okay, so the statement of it is measurements of scientific systems are always subject to variation, some more than others. There are many structures for measurement error and statisticians spend a great deal of time modeling these errors. Suppose the measurement error x of a certain physical quantity is decided by the density function, which is given here as f of x, which lies in between -1 and 1, okay, and 0 otherwise. So what are the options we have here? In part A of it, we have to determine k that renders f of x a valid density function. Okay, so in order to do so, let me solve it here. Okay, and this is part A. So in order to describe any density function and make it as a valid density function, what do we have to do? All these probability densities should be accumulated to give us 1. Okay, so what do we have to do here? I have to take the limits which are from -1 to 1. In this limit, I have to take this f of x dx and it must be accumulated and give me 1, which is basically the condition for a valid density function. Okay, so let me put values here which are the values of f of x. So here this would be -1 1, and here it would be k 3 minus x square, and it should give me 1. Okay, so now in order to do so, this k is constant. Similarly here, now I will have -1 1 3 dx. Okay, this should always be equal to dx here as well. Okay, here also we must have minus and -1 to 1 x square dx. Okay, and it must give me 1. Okay, now let me simplify it, and simplifying it, what I will get here, I will get 3x and -1 1, and also here minus, and here I will get what, x cube divided by 3, because the exponent of it will be summed by 1 and the same will be divided with it over it, and here -1 1, and it should be 1. Okay, now putting the values of these limits, what I will get, let me put these values, and here I will get 3 and 1 minus 1, so here I will get 3 1 plus 1, and here -1 by 3, and here what, here I will get 1 plus 1. Okay, and it must be equal to 1. Let me do it again here, and it will be 3 to 6. Okay, and minus what it will be, it will be 2 by 3. Okay, so it will be 2 by 3 and it must be equal to 1. Let me simplify it further, and it will be 18 minus 2 is 16, so 16 divided by 3, and this is equal to 1, and ultimately it will give me the value of k, which is 3 by 16, and that is the answer of part A of my question, that the value of k is 3 by 16. Okay, so we have done part A of our question. In part B of it, we have to find the probability that a random error in measurement is less than 1 by 2. Okay, so to do so, what do we have to do here? In order to find it out, first of all, we have to find the CDF of it. Okay, so in order to do so, in order to find the CDF of it, what I have to do, I have to take this f of x, I have to find it out, and here I have to take the values from the lower up to certain value, which is x. Okay, and I have to change the domain of my function here as well, and in order to do so, I will change it from x to t. Okay, so the value of k is already known, that is 3 by 16. So 3 by 16, and the value, other values are 3 minus t square and integrated with respect to t. Okay, so here we have it, and integrating it, what I will get, let me try it here as well. So it will be 3 by 16, and here separately integrating each one here, this will be minus 1x 3 dx, sorry, dt, and here minus 1 to x, and here t square dt, and here we have it. Okay, so now let me simplify them. I will get here 3 by 16, and here I will have 3t minus 1 to x and minus t cube by 3, and here minus 1 x. Okay, so simplifying it, and at the end what I will get here, I will get 3 by 16 3 x plus 1. Okay, because x and minus 1 will be plus 1, and similarly here minus 1 by 3, and here this will be x cube, and minus this will be plus 1. Okay. So ultimately what I will get here, ultimately the answer of it will be what? It will be 1 by 16. Okay, and here it will be minus x cube plus 9x and minus 8. Okay, that is what, that is f of x, and that is basically the cumulative function which I had to find out here. Okay, so in order to find the probability that a random error in measurement is less than 1 by 2, what do we have to do here? I have to find the probability that the random error x is less than 1 by 2, and this is what, this is the f 1 by 2. Okay, so let me put their values here in this f of x. What I will get, it will be 1 by 16 and minus 1 by 2 cube, okay, plus 9, 1 by 2 and minus 8. Okay, so here we have it, and ultimately the answer of it, what I will get is 99 divided by 128. This is the answer of part B of my question. Okay, so you have seen that I have found out f of x, and on the basis of it I have found the answer of it. Now part C of my question is, for this particular measurement it is undesirable if the magnitude of the error x, absolute value of x, exceeds 0.8. What is the probability that this occurs, that x exceeds 0.8? So what do we have to do here? I have to find, this is part C of my question, and here I have to find the probability that x absolute exceeds 0.8. Okay, so this exceed is basically what? This is basically the probability that x is less than minus 0.8, okay, or the probability that x is greater than 0.8. I have to encounter both of these cases, and then accumulating it will give me the answer which is required here. So in order to find it out which is less than this one, I can write here very easily by using the CDF, and it will be minus 0.8, while for this one I have to see that this one is what, this is the greater one, so I can find it out by probability of x less than 0.8. Okay, so let me put their values here. So it will be what, 1 plus 1 minus f of 0.8. Okay, now putting these values into what, taking it and then putting the value 0 minus 0.8 here, and then taking this one and putting 0.8 here, what I will get, ultimately the answer of it will be 0.164, and that is what, that is the solution of part C of my question. Okay, so that's it for today, in which we have seen the solution of question 3.30. If you have any question, you can ask me in the comment box. See you soon.